Actuation refers to the type of force used to power the plunger, which pumps the fuel out of the injector. Mechanically actuated fuel systems use a camshaft lobe and rocker arm to provide that force. The rocker arm presses down on the tappet at the top of the injector. The tappet, in turn, presses down on the injector plunger, which pushes fuel from the plunger cavity below the plunger. Fuel displaced from the plunger cavity can flow in two directions. Fuel can flow to the nozzle assembly and to the nozzle tip. However, to flow out of the tip, the injection pressure must reach about 5,000 psi in order to raise the nozzle check against the force of the nozzle spring. The fuel chooses the path of least resistance. It flows around the normally open poppet in the cartridge valve assembly to the fuel supply passage in the cylinder head. When injection is desired, the ECM sends a current to the solenoid on the cartridge valve. The current creates a magnetic field, causing the poppet to close. Fuel flow past the poppet is blocked, and pressure begins to build from the poppet through the plunger cavity to the nozzle check. When the pressure reaches approximately 5,000 psi, the force of the high-pressure fuel overcomes the spring tension holding the nozzle check closed. The check lifts off its seat and fuel flows out of the orifice holes in the nozzle tip. This is the start of injection. The rapid flow of fuel out of the plunger cavity is restricted by the very small orifice holes. Because of this restriction, injection pressure continues to rise very rapidly, even after the nozzle check opens and injection begins. Injection pressures continue to rise until the flow rate out of the orifice holes equals that of the fuel leaving the plunger cavity. Depending on engine speed and fuel delivery, this pressure ranges from 10,000 to 30,000 psi. High injection pressures promote complete combustion and lower exhaust emissions. Pushing the fuel through the orifice holes in the nozzle tip causes the fuel to atomize into droplets in the combustion chamber. Fuel droplets burn from the outside into the center. Large droplets take longer to burn and may not have time to burn completely during a normal combustion cycle. Increasing the pressure of the fuel through the orifice holes creates smaller droplets. In turn, smaller droplets burn more completely